must emphasize pressure and the number of moles are both constant. Okay, and then volume and the temperature in Kelvin are directly proportional. How do we use this equation to do a calculation? Well, here's an example. You have a 5 milliliter syringe of carbon dioxide gas trapped inside a gas-tight syringe at 22 degrees Celsius. Now, if the syringe is immersed into the ice bath, 0 degrees Celsius, we can ask you what's going to be the new volume. The pressure is constant, okay, and the number of moles small, the amount of gas trapped inside, and you're not changing that number. So using the Charles law there, V1 over T1 equals to V2 over T2, we can, we're asking you to figure out, we're asking you to figure out the volume there. So in this case, we have 5.0 milliliter. Now we have at 22 degrees Celsius should equal to X milliliter equals, well, at 0 degrees Celsius. Rearranging the equation, X equals to 0 times 5.2. So that's going to be the volume, right? No. Temperature has to be in Kelvin. Okay. Temperature has to be in Kelvin. You can't plug in 0 into it. That's a mistake people always make when you deal with gas law problems there. Whenever temperature is involved, always remember, convert it into Kelvin. Okay? So the actual volume, once you plug it into the ice bath, their actual volume is going to be somewhere around 4.6 milliliters. Okay? So that's the Charles law, the relationship between the volume and the temperature. And again, every time the temperature is involved, you have to convert it into Kelvin. Now volume can stay in milliliter. It doesn't matter. You don't have to convert the volume into liter. The volume can stay in milliliter, but the temperature has to be in Kelvin. That's something that you must remember, otherwise you're going to make mistakes on the upcoming exam. When you do calculations there, we will give you quantities in milliliters and in Celsius and all that. You have to know what is the correct unit to use for each particular situation. And when we introduce, later on, when we introduce the ideal gas law, PV equals nRT, there is a very specific requirement. The quantities involved in that equation, PV equals nRT, they have to have a very specific unit. If you plug in the wrong unit, the quantity with the wrong unit, you end up with the wrong result. And when you end up with the wrong result, when you take the exam there's no partial credit. Okay? So you need to make sure that you pay very close attention to the units that we're dealing with, the quantities that we're dealing with their units there. The third gas law that we want, individual gas law, that we want to introduce is what we call the Gay-Lussac's law. It deals with the pressure, the relationship between pressure and temperature. Okay? And the math equation represents that law. It says the pressure and the temperature are directly proportional. So P1 equals to P2. And again, temperature is involved. Temperature has to be in Kelvin. So that's something that you want to pay attention to. Volume and the number of moles are held constant. The pressure and the temperature in Kelvin are directly proportional. I don't believe I have a sample question there, but this is the math equation that we have here. The relationship between the pressure and temperature. And again, every time when the temperature is involved, it has to be in Kelvin. I try to put it in red, and I try to emphasize it over and over and over, with the hope that you will pay attention to this particular issue. When you do your calculations there, always convert, whenever the temperature is involved, always convert it into Kelvin. Okay, so and now we have studied the first, the two quantities out of the four quantities that we have there, and that's between the pressure and volume, volume, temperature, pressure, and temperature. Now there is a relationship between volume and the number of moles. Okay, so that's what we say, that's what we call the Avogadro's law. Volume is directly proportional to the number of moles. Well, matter of fact, this is how Amedeo Avogadro discovered, there has to be a relationship between the number of particles and the mass in grams or in pound, whatever, the mass of the matter involved in there. Because when he was studying gas reactions between one another, he noticed that gas molecules always react with one another in whole number ratio. So the number of particles involved in a gas must have something to do with the mass, equal volume. Well, actually, he was studying the volume, the relationship between volume and the number of particles, and the amount of gas involved in there. There's the same volume of gas must contain the same number of particles there. So that's a relationship there. And then Avogadro's law says the equal amount of gases in terms of moles at the same temperature and pressure will occupy equal volume. If you double the number of moles, you double the volume. If you double the volume, the number of moles also doubles there. So this is the math equation that represent the Avogadro's law. V1 over N1 equals to V2 over N2. Now normally we don't want to change the quantities of the gases that we're studying. Okay, so you don't see Avogadro's law calculations involving Avogadro's law on a regular basis there, but there is a relationship there, and we want to use later on. We want to use this relationship to define the density of a gas, because density has something to do with volume. Density also has something to do with mass. Mass has something to do with the number of moles. So you will be able to relate the volume, the gram, well, mass and the volume, and the density together when you deal with the gas problems here. Okay, so Avogadro's law says V1 over M1 equals to V2. Volume is directly proportional to the number of moles. Okay, so you can also prove Avogadro's law by doing an experiment there. Measure the volume, measure the number of moles there, and you end up with a linear relationship. Okay, so these are the 4 individual gas laws that we introduced there. And out of these 4 individual gas laws there, we try to study the relationship between the 2 quantities while holding the other 2 quantities constant. Okay, so in this case, if you combine all of these 4 quantities, not 3 quantities, the pressure, volume, and temperature there, you can say P1 times V1 over T1 would equal to V2 times V2 over T2. That is, when you have a gas system, when you change the pressure, when you change the volume, when you change the temperature, well, this will turn. PV over T stays the same. You can change not just one quantity now, you can change any of the 3 quantities, but this term equals to this term. So you can change the volume to another quantity, you can change the volume to another value, you can change the pressure to another value. For a constant number of moles, P1 V1 over T1 equals to V2 over T2. So we're trying to put all of these quantities together in one equation. This is called general gas law. For a fixed number of moles of gas, P times V over T remains constant. Now combining that with Avogadro's law, number of moles is proportional to the volume there. Okay? So P times V over N times T, that would give you a constant. And that constant is what we call the gas constant. So rearranging the equation, we have PV equals to nRT. Now this equation there, R is what we call the gas constant.